once we're comfortable talking about functions, we can talk about groups of functions that are related to each other in some very specific ways. And sometimes the ways that we relate functions, we talk about families of functions. So as an example, we could talk about the family of functions of the form f of x equals x to the n, where n is a positive integer. And so what this means is, so here's a function where it looks like f of x equals x to the n, and that n is allowed to be considered as having different values. So this particular graph is f of x equals x to the first power, and here we have f of x equals x to the fifth power. And so this whole collection for all values of n is a family of power functions. Okay. And so this is the family of power functions where the power is a positive integer. All right. And in terms of like representing this in Desmos, this is something where I can, so I basically just typed this in as f of x equals x to the n, and it offered to let me make this a slider. And so this makes it a slider that has no restrictions on what the value can be. So I wanted it to be only positive values. So this is the range set for the slider. And so I set the range to be a minimum of 1. And I decided to go ahead and make the maximum at 20. And I said step by 1. Okay, so that means that I'm not going to get any fractional exponents. Okay, so this is one way to represent this family of functions, but it requires some animation. And so another way to represent this family of functions is to define n to be a list. And in Desmos, they use square brackets to make a list. So I'm just going to choose some representatives and choose n equals 1, 2, 3, and I can go ... to 20, for example. And so that is graphing all at once. It's graphing f of x equals x to the first power, f of x equals x to the second power, f of x equals x to the third power, all the way up to f of x equals x to the 20th power. Okay, so this is a pretty powerful way to visualize these families of functions. And you can change these lists. So instead of counting everyone, maybe I just want to count the odd ones. And so I could look at just the family of power functions where the power is an odd positive number. Okay, or I could go from, say, -1 to -8. Oops, -8. And that would give me a family of power functions with negative powers. All right. So that was a little bit of a digression on how to put this into Desmos, but this is basically looking at a collection of different functions where some of the parameters that define the function are the same and some of the parameters are allowed to vary. So, I mean, another example that you might try is, say, I'm going to turn this off. The family of functions, of linear functions, where the slope of the line is, say, I don't know, -2/3. Okay. So I know that linear functions look like L of x equals ax plus b, right? And a is the slope, so I'm gonna put in -2/3 as the slope, and then I have a b. So like filling this in for any given b value gives me one line out of this family of linear functions. Okay, so this would be a way to depict all of like the full family of linear functions where the slope of the line is -2/3. All right, and you can choose how you're going to represent that in Desmos. You can represent it with a slider, or you can represent it with a list. So say -10 to 10. There's a bunch of representatives as a list. But actually just representing algebraically this family of functions is right here.